What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. And what we're going to be talking about today is how we can change quadratic functions from standard form into vertex form. If you're just getting here now, make sure you go back and watch my previous video. In that video, we took things that were in vertex form and put them into standard form, the opposite of what we're going to be doing today. Let's jump right into it by reviewing the three different forms of quadratic functions. In our last few videos, we've talked about the three forms of quadratic functions, so I won't spend much time talking about them here. We have standard form, vertex form, and factored form. We learned in our last video how to go from vertex form to standard form, and once we were in standard form, we could go to factored form. Today is going to be a different process, which is much more difficult. We're going to go from standard form into vertex form. Before we can do that, we have to introduce the definition of a perfect square trinomial. A perfect square trinomial is a three-term polynomial that when factored has two of the same binomial factors. Think about this example here, x squared plus 10x plus 25. Well, this is a trinomial, so we know it would factor like this, and to find the two numbers that go into the blank, we would just find two numbers that multiply to 25 and add to 10. Those two numbers would be 5 and 5, so we could see that when we factored this, it had the same two binomial factors of x plus 5 and x plus 5. That's what makes it a perfect square trinomial. One thing that we're going to be doing in this video is learning how to build our own perfect square trinomials. Let's think about these two examples. In both question 1 and in question 2, we have two binomials, and we want to think what constant could we add to each in order to make them perfect square trinomials. Let's first look at number 1. Here I want to know what constant could I add to this expression so that it would become a perfect square trinomial. In order to find that number, you take half of the b value, square it, and add it to the trinomial. Here I can see the b value is negative 6. Half of that would be negative 3, and when I square negative 3, I would get 9. Adding 9 to this creates a perfect square trinomial. Why? Well, think about it now. I need two numbers that multiply to 9 but add to negative 6. Those numbers would be negative 3 and negative 3. Hence, x squared minus 6x plus 9 is a perfect square trinomial. Let's do the same thing for number 2. What happens is you take half of the b value and square it, and you can create a perfect square trinomial. Here the b value of 8 is 4, and when you take 4 and you square it, you get 16, meaning adding 16 to this binomial would create a perfect square trinomial. In order to check that it is, let's just factor it to make sure that we get the same two binomial factors. Well, because this is a trinomial, we know it factors just like this. And I just have to find two numbers that would multiply to 16 and add to 8. In this case, it's positive 4 and positive 4. So you can see that we did create a perfect square trinomial. Let's see if you can try one of these examples on your own. What constant could you add to x squared plus 4x to make it a perfect square trinomial? In order to create a perfect square trinomial, you take half of the b term and square it. In this case, the b term is 4. Half of 4 would be 2, and when we square 2, we get 4. So the number that you would add to this binomial is 4 to make it a perfect square trinomial. Let's check this by factoring. First, we'll rewrite our binomial x squared plus 4x. We said to make it a perfect square trinomial, we were going to add 4. If we went to factor this, we would use trinomial factoring and find two numbers that multiply to the c term of 4 and add to the b term of 4. Those numbers, of course, are positive 2 and positive 2. This is a perfect square trinomial. Let's try another one of these examples. In this problem here, what constant would you add to x squared minus 20x to make it a perfect square trinomial? In order to create a perfect square trinomial, take half of the b term and square it. The b term in this example is negative 20. Half of negative 20 is negative 10, and when we square negative 10, we get 100. 100 is the constant that we should add to create a perfect square trinomial. To check our answer, let's rewrite our binomial, put the constant term of 100 there, and factor it just to make sure that it does have the same two binomial factors. Well, this is a trinomial, so it's going to factor like this. We'd find two numbers that multiply to 100 and add to -20. Those two terms are -10 and -10. One thing that you should start to notice, if you haven't noticed already, is when you factor a perfect square trinomial, the number that goes in the blanks here was always half of the b term. That is always the case by construction, that when you factor it, the binomial that repeats is the same as half of the b value. Now that we've learned how to create perfect square trinomials, let's use that information to change quadratic functions from standard form to vertex form. These are the steps to change a quadratic function from standard form to vertex form. The first step is to put the quadratic equation in the following form. It's very similar to standard form, but the coefficient of your x squared term needs to be 1. In step 2, you're going to find some constant, which we'll call m, that would create a perfect square trinomial for 1x squared plus bx, which is the first two terms. The way that we do that is, of course, you take half of the b value and square it. For this step, you can ignore the c term. It has no bearing on that constant value m that we're creating in order to make a perfect square trinomial. In step 3, you're going to take that value of m from step 2 and add it and subtract it to your trinomial. In step 4, you'll combine the constant terms and factor the perfect square trinomial you created in step 5, and finally you'll have this in vertex form by just writing the binomials squared. Let's look at an example of this to bring it all together. In this example here, we want to take this quadratic function, which is written in standard form, and we want to place it into vertex form. In order to place this into vertex form, the first step is going to be to create that perfect square trinomial. In order to do that, we'll take half of the b value, square it, and add it and subtract it to this quadratic function. The b value here is -14. And when I take half of -14, I'm going to get -7, and -7 squared will be 49. We can now use 49 to create a perfect square trinomial, and we'll add and subtract it to our original function like this. The whole purpose of adding and subtracting this here is twofold. First of all, these two terms here, when I combine them, just sum to 0, so we didn't actually change the value of the function. The second reason we added and subtracted 49 in this example was because right here we created a perfect square trinomial. What we'll now do is combine these two like terms on the outside and factor this perfect square trinomial to the left of it. Well, -49 plus 9 is -40, and I know this is a trinomial, so it's going to factor like this. Factoring the trinomial, I know I need two numbers that multiply to 49 and add to -14. Anytime we have something that multiplies to a positive and adds to a negative, they'll both be negative. In this case, those two values are -7. Remember that the values from when you factor are the same value that you got here when you took half of the b value. Finally, to write this in vertex form, just write it as a binomial squared, which means instead of x minus 7 times x minus 7, we can just write this as x minus 7 squared, and of course bring down the -40. This is now written in vertex form, and we could even write the vertex now if we want. The vertex has an x value that's opposite of what's inside, and a y value as the same as what's outside, giving us a vertex of 7, -40. Let's see if you could try one of these examples on your own. Which of the following represents g of x written in vertex form? In order to change something from standard form to vertex form, we have to create a perfect square trinomial. Here we have g of x written in standard form. In order to create a perfect square trinomial, we're going to take half of the b value and square it. The b value here is 6, half of 6 is 3, and when we square 3, we get 9. This is the value that would create a perfect square trinomial when added to g of x. Of course, we just can't add g of x or add 9 to g of x without changing the value of the function, so we add 9 and subtract 9 from g of x as to not change the value of the function. These left three terms are a perfect square trinomial that will factor. These right two terms are just constants that we can combine. Negative 9 plus 8 is negative 1, and I know the three terms to the left will factor. To factor those, I need two numbers that should multiply to 9, but also add to 6. Anytime they multiply to a positive, but also add to a positive, both numbers will be positive. In this case, the two numbers that do that will be 3 and 3. I might have been able to predict that these numbers would have been 3 because half of the b value is 3. That will always match when creating perfect square trinomials. Finish factoring by putting the numbers in the blank, and then write this in vertex form by writing this binomial product as a binomial squared. Here we can see we have written g of x in vertex form, and further we can use this to find the vertex. I know for the vertex it's the opposite sign of what's on the inside for the x value of our vertex, and the same sign as what's outside for the y value of our vertex. This gives us a vertex of -3, -1. Let's try another example. In problem number 2, complete the square to rewrite the quadratic function y equals x squared minus 10x minus 6 in vertex form. Here, if we rewrite the function, we can see that it was given to us in standard form. When a function is given to us in standard form, we can actually look at it and find the y-intercept, recalling that the y-intercept is the coordinate 0, c, where c is the constant when this is written in standard form, which gives us a y-intercept of 0, -6. That information doesn't help us to solve this problem because we want to write this in vertex form. In order to write a quadratic function in vertex form, we have to complete the square. In order to do that, we'll take half of the b value and square it. Well, the b value here is -10, and half of -10 is -5. Squaring -5 is -5 times -5, or 25. 25 is the value that could take this from standard form and put it into vertex form by creating a perfect square trinomial. In order to create a perfect square trinomial, we want to add and subtract 25 from this function, like so. The first three terms here is a perfect square trinomial, and the last two terms we can just combine as a constant. Well, -25 minus 6 is -31. When we go to factor this trinomial, we need two numbers that multiply to 25 and add to -10. Anytime two numbers multiply to a positive yet add to a negative, both numbers will be negative, and those two numbers are -5 and -5. You could have predicted that since half of the b value is -5. Let's take that number and fill it in the blanks. Now to change this into vertex form, just write this binomial product as a binomial squared. You'll get y equals x minus 5 squared minus 31. Of course, because this is in vertex form, we can easily find the coordinates of the vertex. The x value of the vertex is the opposite of what's written on the inside, and the y value of the vertex is the same as what's written outside. That means the vertex for this function is the coordinate 5, -31. Let's try another example. In this problem here, find the coordinates of the vertex by putting the quadratic function into vertex form. If we rewrite the function here, we can see that this is written in standard form. In order to put this into vertex form, we need to complete the square by taking half of the b value and squaring it. The b value is 2, half of 2 will be 1, and 1 squared will also be 1. 1 is the value that can create a perfect square trinomial from our original function. We should add and subtract 1 from this function so that we have a perfect square trinomial. This first part here is a perfect square trinomial. The last two values we can just combine as a constant. -1 minus 3 is -4, and when we factor this trinomial, we need two numbers that multiply to 1 and add to 2. Those two numbers are both +1, which you may have guessed because that was half the b value. Placing +1 and +1 in the blanks, we can change this into vertex form. To identify the vertex, remember that the x value of the vertex is the opposite sign as what's on the inside, and the y value has the same sign. That makes the vertex of this function the coordinate -1, -4. Let's try one final example. In this problem here, which of the following functions represents m of x when it's written in vertex form? When we rewrite m of x, we can see that it's written in standard form. In order to take something from standard form and put it into factored form, we have to complete the square. In order to complete the square, take half of the b value and square it. The b value here is 3. When you take half of 3, you get 1.5, and 1.5 squared is 2.25. Now don't get discouraged because you have decimals here. The process is the same. We now take 2.25 and add and subtract it from our original function m of x. These first 3 terms are our perfect square trinomial, and the last 2 terms are just some constants that will combine. Negative 2.25 and negative 7 become negative 9.25, and we can just factor this perfect square trinomial. We need 2 numbers that multiply to 2.25 and add to 3. You might be thinking, well, I don't know what multiplies to 2.25. It's okay. We know when these factor, it's always half the b value, so the terms that do that are just 1.5 and 1.5. Take the value of 1.5 and just place it in the blanks, and in order to change this into vertex form, just write this binomial product as a binomial squared. Well, that's it for this video, and that's it for me. I hope in this video you learned how to take things that were written in standard form and put them into vertex form by completing the square. Until next time.